So this question depends on you knowing the core knowledge around testing for gases. In this case, it's hydrogen. And if we ignite hydrogen when it's mixed with air, what will happen is it will burn with a squeaky pop, making a squeaky pop sound. Okay, this is some data. Always look at tables carefully and make sure we use the patterns of the data in our response. It says use the data to show what results show about the volumes of hydrogen and oxygen produced in this experiment. So the first thing we can see is as the time goes on, the volume of each of these increases. So that's my first point. So the volume of each gas increases during the experiment. The second point here is spotting that each time you go across, we're getting twice as much hydrogen. So there's twice as much hydrogen as oxygen produced. So the volume of hydrogen is double the volume of oxygen every 2 minutes. Okay, 2 marks, 2 points. Okay, so we've got molten, so that means there's no water, so we're just dealing with the ions in the ionic compound. So I can only produce lead and then bromine. So the only option is lead and bromine. So that is option C. Calcium nitrate and ionic compounds. We create a mixture and calcium nitrate behaves as an electrolyte. Remember, electrolyte, again, core knowledge, means that the ions are loose, the ions are free to move. Calcium carbonate does not behave as electrolyte, explained in terms of solubility. So what's happened here, we've taken two ionic compounds, the one that's become an electrolyte, the ionic lattice is broken, and therefore the ions are free to move. So I'm going to put here, because I've got to get 2 marks, so calcium nitrate is soluble in the water. So calcium nitrate is soluble in the water. And then I would say that the lattice is broken, so the ions are free to move. And that gave me a 2nd mark. So this question is talking about the electrolysis of copper sulfate using copper electrodes. This is the purification of copper. It's a 6 marker. And what I've done to try and help with this is break this down into a number of sections, because I think that helps structure the response and your thinking. So we've got to explain some observations. The first one is that the anode and cathode change in size. A solid appears underneath the anode, and the final one is that we get copper sulfate solution does not change colour. So I've actually broken these two down into 1 and 2 just to help with my explanation. So the first bit I'm going to deal with is the cathode. So in the solution here, we must remember that because this is copper sulfate solution, we have got copper ions inside this solution, and they're crucial to what's going to take place during this reaction. So the copper ions that are in the electrolyte are attracted to the cathode because they are cations, positive ions, and they go to the cathode. At the cathode, the copper ions gain electrons to form copper atoms. And I've given you the equation here. So you've got Cu2 plus being attracted across. We add 2 electrons to get rid of this get rid of this positive charge, and that forms copper atoms with no charge. This is an example of reduction because this is gaining electrons. As this forms, we get brand new, and that's these red shaded bits here, brand new copper starts to form on the surface of the cathode. And because we've got new copper forming, this makes the cathode increase in size. The opposite at the anode takes place. So the anode is made from copper, and the anode is impure. So this is copper with some impurities in it. And what happens here is the copper metal atoms, they form copper ions, and to do that, they have to lose electrons. This equation here shows that taking place. So there's my copper atoms with no charge. They form copper positive ions, and to get a positive ion, they must have lost these electrons. Because this is losing electrons, remember loss of electrons is oxidation, and the ions that form go into the electrolyte. So we've got copper atoms becoming ions and going into the electrolyte. This means that the anode is going to become smaller as this reaction takes place. We then, as that reaction takes place at the anode, underneath the anode, we start to get sludge forming, and the sludge are insoluble impurities that sink to the bottom of the beaker. And these impurities have all come from the anode, which is why they sink underneath it. And literally, as the copper starts to come off, anything that's impure will sink to the bottom and just collects at the bottom as this sludge. So there's the 3 bullet points to describe the solid. The final stage is explaining why the color of the solution doesn't change. And it doesn't change because we have got copper ions coming out of solution, forming brand new copper atoms. And if that happened on its own, we would have fewer copper ions in the solution. The copper ions are the reason this solution is blue, and therefore the blue color would start to fade. But that doesn't happen because here your copper atoms at the anode start to break down and form ions, and they go back into solution, and that means the concentration of ions in the solution doesn't change. So as they're being removed here, they're being added here, and those two processes equal, so therefore the concentration of these doesn't change and the color does not change either. So here's your bullet points that I've talked about for this one. And overall, I've got 17 bullet points listed. So if you've got over 15, then give yourself 6, and you can see the idea. Over 12 to 14 is 5, and so on to get your mark for that particular answer.